Imagine having an AI that can actually browse the web for you, like book that trip you've been putting off, or snag that limited edition sneaker drop, or even handle those tedious expense reports.
Right.
It sounds like something out of a sci-fi movie, right?
It does.
But get this, researchers at Tsinghua University and Zipu AI are making it a reality. And we're going to dive deep into their work today.
Yeah, it's fascinating stuff.
Yeah.
They've developed this system called WeBRL that's training open source AI models, specifically large language models, or LLMs for short,
LLMs.
to interact with websites just like we do.
Okay, so let's back up for a second. I get that LLMs are like the brains behind AI chatbots and all that, but how do they even work on the web?
Yeah.
I mean, a website isn't exactly a text document.
Right. That's the challenge this research tackles head on.
Huh.
Up until now, the really impressive AI web agents relied on these super powerful, but also super expensive and proprietary models.
Oh, okay.
Like GPT-4. What's exciting about WeBRL is it's showing we can achieve comparable and sometimes even better performance using open source LLMs, which are much more accessible.
So WeBRL is like a training program for these open source models, teaching them to navigate the web.
Exactly. Think of it like this. WeBRL provides the structure and the guidance for the AI to learn, kind of like a teacher showing a student the ropes. And they've had some remarkable success. They trained an open-source LLM called Llama 3.1 using WeBRL, and it's outperforming even GPT-4 on certain web tasks.
Wow, that's a major upset.
Yeah.
But what kind of tasks are we talking about here? Give me some real-world examples.
They tested these models on a benchmark called WebArena-Lite, which is essentially a collection of real websites with a variety of tasks the AI needs to complete.
Okay.
We're talking about sites like OpenStreetMap, where the AI might have to find a specific location, or Reddit, where it might need to find a particular post or comment. It even tackles trickier stuff like GitLab, content management systems, CMS, and even an online shopping platform.
So it's not just simple stuff like clicking links.
No.
We're talking about navigating complex websites and completing specific goals. But how does WeBRL actually teach these LLMs to do all that? It must be more than just pointing them at a website and saying, go.
Right. That's where it gets really interesting. WeBRL uses a few clever techniques, and one of the most important is what they call a self-evolving curriculum.
Okay.
Imagine a personalized training program for the AI, starting with super basic tasks on the web, and then gradually increasing the difficulty as it learns.
So it's like starting with find the big red button and working up to book me a flight to Paris with a layover in Rome, but only if the price is under $1,000.
That's a great way to put it.
Okay.
And the key is that the curriculum is always adapting to the AI's skill level. If it's breezing through tasks,
Right.
the WeBRL throws in harder ones. If it's struggling, it dials things back a bit. This constant adjustment keeps the AI challenged, but not overwhelmed, leading to much faster and more effective learning.
Okay, that's pretty cool. But how does WeBRL know if the AI is succeeding or failing at these tasks?
Right.
Especially on something complex like booking a flight. You can't just give it a point for every click, right?
You're absolutely right. And this is another major challenge in training. AI web agents, often you only get feedback on whether it succeeded at the very end. To address this, WeBRL uses something called an Outcome Supervised Reward Model, or RRM for short.
Okay, break that down for me. What is an RRM and how does it help?
Think of the RRM as a judge that observes the AI's entire interaction on a website. It doesn't care about the individual steps, but looks at the final outcome. Did the AI successfully book the flight? Did it find the right information on Reddit based on that outcome? The RRM gives a simple yes or no signal. And that's the feedback the AI uses to learn.
That's clever. It's like saying, I don't care how you get there as long as you reach the destination.
Exactly.
Yeah.
And this is a major breakthrough for training web agents, because traditional methods often rely on giving feedback at every step, which just isn't realistic for complex web tasks.
Right.
The RRM lets the AI learn from its successes and failures without needing constant hand-holding.
I see how that would be a game changer. But what about the problem of the AI forgetting what it's learned? I've heard that as these models evolve, they can sometimes lose track of older skills, like if you learned to ride a bike as a kid but forgot as an adult because you only drive cars now.
That's another insightful point, and it's definitely a concern in AI. It's called policy drift. As the AI learns new things, its behavior or its policy shifts, and it can sometimes lose those earlier skills. To combat this, WeBRL incorporates a special algorithm called the KL-constrained policy update.
Okay, I'm sensing a technical deep dive coming on. Can you explain that one without losing me
All right.
completely?
Think of the KL constrained policy update as a safeguard that prevents the AI from changing its behavior too drastically from one learning session to the next. It's like setting boundaries so it can explore new strategies on the web without completely abandoning everything it already knows.
So it's like encouraging the AI to try new things while reminding it, hey, don't forget those awesome skills you already picked up.
Exactly. And this balance between exploration and remembering is crucial for the AI to continue improving over time. Without it, it might get stuck in a rut or even start making more mistakes as it forgets its previous successes.
I'm starting to see how all these pieces fit together. The self-evolving curriculum keeps the AI challenged, the ORM provides clear feedback even on complex tasks, and the KL-constrained policy update ensures it doesn't forget what it's learned. But let's get back to those impressive results you mentioned. How much better did Llama 3.1 actually perform after training with WebRL?
The numbers are pretty remarkable. Before WebRL, Llama 3.1 had a success rate of only 4.8% on WebArena-Lite. That means it was basically failing most of the tasks. But after training with WebRL, its success rate jumped to a whopping 42.4%.
Wow, that's an incredible improvement.
Yeah,
But how does that compare to the performance of those powerful models like GPT-4?
that's the really exciting part. On the same WebArena-Lite benchmark, GPT-4 Turbo only achieved a 17.6% success rate, and GPT-4o got 13.9%. So we're talking about an open source model trained with the WebRL outperforming some of the most advanced AI systems in the world.
That's huge. It really seems like WebRL is living up to its hype. But before we get too carried away, let's dig into some of the specific details from the research paper. I always find that the real-world examples make these concepts much easier to grasp. What are some of the things that stood out to you?
One thing I found particularly insightful was their analysis of the types of errors the AI made. They discovered that WebRL was especially effective at reducing errors, where the AI got stuck in a loop, repeating the same action over and over without making progress.
That makes sense. With the constant feedback from the ORM and the ability to learn from past experiences, it's like the AI is always evaluating its progress and course correcting when it realizes it's going in circles.
Precisely. And they also found that WebRL helped the AI recover from failures more effectively. Instead of just giving up when it hit a snag, it was better at trying a different approach, almost like it was learning to be more resilient and resourceful.
It's like it's not just about finding the right answer, but also about developing those problem-solving skills, which is pretty cool. But let's dive into some specific examples from the paper. Those always help to paint a clearer picture of what the AI can actually do.
Okay, here's one that I found really interesting. They gave the AI a task on the CMS website, which is used for managing website content. The goal was to find the order quantity from a specific date range. The initial instruction they gave the AI wasn't very clear, and it struggled to figure out what to do.
It's like giving someone vague directions and then wondering why they got lost.
Exactly. But here's where WebRL's self-evolving curriculum comes in. It recognized that the AI was struggling and generated a slightly modified instruction that was more specific.
Okay.
And with that little tweak, the AI was able to figure out how to complete the task successfully.
So it's like the AI learned from that clarified instruction and then applied that knowledge to the original trickier one. It's like having a student who asks clarifying questions instead of just blindly trying to guess the answer.
Yes, and that really highlights the power of this iterative learning process.
Yeah.
The AI isn't just passively following instructions, it's actively trying to improve its understanding of the task.
Right.
It's like it's learning to think for itself.
It's pretty amazing to see how far this technology has come. But I'm curious, did they test WebRL on larger, more powerful models too?
Absolutely. They also trained a much larger version of Llama, the 70B model, with WebRL. And as you might expect, the results were even more impressive. It achieved a 49.1% success rate on WebArena-Lite.
Wow, so it seems like the benefits of WebRL really amplify as the models get larger. It's like giving a talented athlete access to a world-class training facility. But what about that ORM we were talking about? How did they know it was actually working so well?
They didn't just assume it was great. They put it to the test. They compared their ORM to several other methods, including using GPT-4 Turbo for the same task. And you know what? Their ORM outperformed all of them, achieving an accuracy of around 80%.
That's pretty remarkable considering it was going up against the mighty GPT-4. It really speaks to the ingenuity of their approach.
Yeah.
But before we wrap up this part of our deep dive, I'm curious about your thoughts on the broader implications of this research. Where do you see this technology going?
If you think about the bigger picture, making powerful AI web agents accessible through open source models is a potential game changer. Imagine a world where anyone can build their own personalized AI assistant capable of automating their online tasks, all without needing access to those expensive proprietary models.
It's like democratizing access to this incredible technology. It could be incredibly empowering for people who might not be able to use traditional web interfaces, maybe due to disabilities or other limitations.
Absolutely. This research has the potential to make the web more accessible and inclusive. And this is just the beginning. Who knows what other incredible applications we'll see for AI web agents in the future?
It really sparks the imagination, doesn't it? This research offers a glimpse into a future where AI becomes an integral part of our online lives, helping us navigate the increasingly complex digital world. But before we get too lost in the possibilities, let's shift gears and explore some of the practical aspects of WBRL in a bit more detail. We've touched on the key mechanisms, but I think it's worth delving deeper into how they work and why they're so innovative.
Let's start with that self-evolving curriculum. It's one of the most ingenious aspects of WBRL. It's based on this idea that learning for both humans and AI is most effective when it's personalized to the learner's current abilities. Think of a good teacher who adjusts their lessons based on how well their students are grasping the material. That's essentially what WBRL is doing for the AI.
So it's not just throwing the AI into the deep end and hoping for the best.
No, not at all.
It's more like a carefully crafted training plan that adapts as the AI learns.
Exactly. It starts by analyzing the AI's performance on previous tasks, specifically pinpointing the areas where it struggled or failed. It then uses those challenging tasks as inspiration to create new ones that are similar in nature but slightly modified.
It's like taking that math problem the student got wrong and creating a similar one with different numbers to help solidify the concept.
That's a great analogy.
Mm-hmm.
The key here is that these new tasks are designed to be just slightly more challenging than the ones the AI previously stumbled on. This ensures that it's always being pushed to learn and improve, but not so much that it gets discouraged or overwhelmed.
It's about finding that sweet spot where the AI is engaged and motivated to learn. But I'm curious, how does WBRL actually generate these new tasks? Does a team of researchers sit there coming up with endless variations?
You might be surprised to hear that they're actually using another AI for this GPT-4o. It's a bit ironic, but they're using one of those powerful proprietary models we talked about earlier to generate the training data for the open source model.
So it's like enlisting a master chef to help create a recipe book for aspiring cooks.
That's a fantastic way to put it. They're using GPT-4o because it's incredibly good at generating creative and coherent text. In this case, they feed it a task description, and it spits out a variety of similar tasks that still make sense in the context of the website.
So it's like having a brainstorming partner that can come up with new ideas and variations that the researchers might not have considered.
Exactly.
Yeah.
Of course, they don't just blindly accept everything GPT-4o generates. They have a critic model that evaluates each new task and filters out any very shorter that don't meet specific criteria.
It's like having a quality control team that ensures the training material is top-notch and actually relevant to what the AI needs to learn.
Precisely. And they do some manual checking too, just to be extra careful. It's a combination of AI and human oversight to create this incredibly dynamic and effective learning environment.
That makes a lot of sense. So we've got this personalized training program adapting to the AI's progress, but how do they actually assess whether the AI is succeeding or not?
Right. That's where the outcome supervised reward model, the ORM, comes into play. Remember how we talked about the challenge of sparse feedback in web tasks? The fact that you often only know if the AI did the right thing at the very end?
Right. You can't exactly give it a point for every click or keystroke, especially when the goal is something complex like booking a flight.
Exactly. Traditional reinforcement learning relies on frequent rewards to guide the learning process. But that doesn't work well here. The ORM is designed to address this challenge by acting as a surrogate for that delayed reward.
So instead of getting a treat for every step, it's like the AI is working towards a final goal and gets a big reward when it gets there.
That's a great way to think about it.
Yeah.
The ORM looks at the AI's entire interaction with a website and makes a judgment call based on the final outcome. Did it successfully book the flight? Did it find the right information on Reddit? It outputs a simple yes or no signal based on whether the ultimate goal was achieved.
That's pretty ingenious. It's like saying, I don't care how many wrong turns you took as long as you ultimately found your way to the destination.
Exactly. And that's a major breakthrough for training AI agents to operate in the real world. Traditional methods often struggle with complex tasks because they rely on giving feedback at every step, which just isn't practical or even possible in many cases.
I can see how that would be limiting. But how does the ORM actually learn to make those judgments about success or failure?
They train it on a data set of human-labeled examples. So essentially, it learns to mimic human judgment about task completion.
So it's like It's learning to see the web through human eyes, understanding what we consider to be a successful outcome.
Precisely. That's what makes the ORM so effective. It's not just relying on some arbitrary metric of success, it's aligning the AI's behavior with human expectations and goals.
It's like bridging the gap between AI and human understanding of what it means to complete a task online. But how did the researchers make sure that ORM was up to the task? I imagine training it requires a lot of data.
You're right. Training a robust ORM requires a diverse and comprehensive data set. They started with the human annotations from WebArena-Lite, which already includes judgments on whether the AI agent succeeded in each task.
So they're leveraging the human knowledge that's already built into that benchmark.
Exactly. But they also went a step further and augmented the data set with examples from WebArena, which is the full version of the benchmark. And they even collected additional data by having the AI agent interact with the websites and then having humans evaluate its performance.
It's like giving the ORM a well-rounded education, exposing it to as many scenarios and outcomes as possible so it can learn to make those judgments accurate.
Got it. And they didn't just assume it worked.
Yeah.
They actually tested it against other methods, including using GPT-4 Turbo for the same task.
And how did their ORM fare against the competition?
Their ORM outperformed all the other methods, achieving an impressive accuracy of around 80%, even when compared to GPT-4 Turbo.
That's really impressive. It sounds like the ORM is a key ingredient in WebRL's success. But we've talked about this idea of policy drift, where the AI can forget previously learned skills. How does WebRL prevent that from happening?
That's where the KL-constrained policy update comes in. It's designed to prevent the AI from drastically changing its behavior as it learns.
So it's like a safety net, allowing the AI to explore new approaches, but making sure it doesn't stray too far from what it already knows how to do.
That's a good way to think about it. Imagine you're learning a new song on a musical instrument. You've already mastered the first few bars, but now you're moving on to a more challenging section. If you focus too much on the new part, you might start to forget how to play the earlier parts.
It's like my brain can only handle so much new information at once.
Exactly. The KL-constrained policy update works by setting a limit on how much the AI's behavior or its policy can change from one learning session to the next. It ensures that the AI can explore new possibilities while retaining the valuable knowledge it has already gained.
So it's like having a music teacher reminding you to keep practicing the earlier parts of the song even as you're tackling the more challenging sections. It's about maintaining that balance between exploring new skills and retaining the ones you've already mastered.
Precisely. And this is critical for the AI to continue improving over time. Without this constraint, it's possible that it could lose valuable skills or even regress in its performance as it learns new things.
That makes a lot of sense. It's like making sure the AI is always building upon its existing knowledge base, not just randomly jumping from one idea to the next and forgetting everything it learned along the way.
Exactly. This balance between exploration and remembering is crucial for the AI to continuously improve its ability to navigate the web and complete tasks effectively.
This has been a fascinating deep dive into the world of WebRL. It's incredible to see how these researchers are pushing the boundaries of what's possible with AI web agents, especially using open source models. But there's one more piece of the puzzle we need to talk about: the experience replay buffer. Can you explain what that is and why it's so important?
The experience replay buffer is fascinating. It's like giving the AI a library of its best moments, a collection of past successes it can revisit and learn from.
It's like having a highlight reel of those game-winning shots or perfectly executed plays. Athletes often review their best performances to analyze what worked and reinforce those winning strategies.
That's a great analogy. In the context of WebRL, the experience replay buffer stores snippets of the AI's past interactions on websites. Each snippet includes information about the situation the AI was in the action. It took the outcome of that action and any rewards it received.
So it's like capturing the entire sequence of events, from the initial state of the website to the AI's action and the resulting change. It's almost like creating a playbook for the AI to reference.
Exactly. And during the training process, the AI can randomly dip into this buffer and replay those experiences. It's like reliving those moments of success, allowing it to reinforce the strategies that worked well in the past.
It sounds like giving the AI a chance to practice and refine those winning moves, even if those situations don't come up again in the current training session.
That's exactly right. And this replaying is beneficial for several reasons. First, it exposes the AI to a much wider range of experiences than it might encounter in a single training session. It's like a basketball player studying game tapes from various opponents and scenarios, not just practicing against the same team every time.
That makes sense. By drawing from a larger pool of past experiences, the AI can become more adaptable and versatile in its approach to different web tasks.
Exactly. And the experience replay buffer also helps address a common challenge in reinforcement learning called correlated data. In simpler terms, this means that the AI's actions often depend heavily on what's currently happening on the website. It can get stuck in a pattern of taking the same actions in similar situations.
So it's like developing a habit, and sometimes those habits aren't the most effective way to approach a problem.
Right. But the experience replay buffer helps break those patterns by randomly sampling from a diverse set of past experiences. It's like mixing up the practice routine, forcing the AI to consider different actions and approaches it might not have tried otherwise.
So it's encouraging the AI to think outside the box and explore a wider range of possibilities.
Precisely. And lastly, the experience replay buffer is especially helpful in situations where the rewards for success are infrequent, which is often the case with complex web tasks.
Right, because the AI might only get that reward signal that, yes, from the ORM at the very end of a long sequence of actions.
Exactly. The experience replay buffer lets the AI relive past successes and get those reward signals more often, even if it hasn't actually completed the entire task in the current training episode.
So it's like giving the AI more frequent encouragement and reinforcement, even if it's just practicing individual steps or components of a larger task.
That's a great way to put it. And all of these benefits together make the experience replay buffer a crucial element in WebRL's success in training these open source LLMs to become truly capable web agents.
This has been an incredible journey exploring the world of WebRL and its potential to revolutionize how we interact with the web. We've covered the challenges, the innovative mechanisms that make WebRL so effective, and even glimpsed into a future where AI seamlessly navigates the online world on our behalf. But we want to hear from you, our listener. What are your thoughts on this research? Does it spark excitement, concern, or maybe a bit of both?
And remember, the researchers have made their code and data publicly available. That's a huge step towards fostering collaboration and accelerating progress in this field.
Exactly. Imagine a community of researchers and developers building upon this work, pushing the boundaries even further. Maybe someone listening right now will be inspired to create the next breakthrough in AI web agents. The possibilities are truly endless.
It's exciting to think about the future applications. We've discussed AI agents automating tasks, but what about them collaborating with each other online? Could we see AI agents forming partnerships, negotiating deals, or even competing in online marketplaces?
It's a mind-boggling thought. A web filled with AI agents interacting with each other, creating a whole new layer of complexity and dynamism. It might seem like something straight out of science fiction, but it could be closer than we think.
And that raises all sorts of intriguing questions. How do we ensure these AI interactions are fair and beneficial? How do we prevent unintended consequences or harmful behaviors? It's a reminder that as we develop these powerful technologies, we also need to think carefully about their impact on the digital world we're shaping.
It's a call to action for all of us, researchers, developers, policymakers, and even everyday users to participate in shaping this future. We need to ensure these technologies are used responsibly and ethically to create a web that benefits everyone.
Well said. And on that note, we'll leave you to ponder the possibilities. Until next time, keep exploring, keep questioning, and keep diving deep.